All right, our next section here is stuccos. And I'm going to go back and forth from these two slides. I'm going to expect you to be able to tell the difference, both from looking at it from the outside, well, only from looking at it from the outside, but I want you to know the difference between a 2-coat stucco and a 3-coat stucco. So let's go back and forth. The first picture we had on there was a 3-coat stucco. 3-coat stucco is for wood frame structures. 2-coat stucco is going to be for masonry structures. All right. So let's go back and build our 3-coat stucco wall. So we got a wood frame structure going up underneath here. You know, what's not showing is our insulation, our vapor barrier, drywall, plaster, whatever's on the inside. That's not showing. What is showing is our sheathing on the outside. Now this sheathing, when we're dealing with stucco, this cannot be Celotex. This cannot be the black insulation. It can't be any type of styrofoam. It has to be wood. All right. It could be plywood. It could be OSB, but it has to be some sort of strong, solid, not flexible base that's going to be holding on to this material. All right. Now, because we're putting something that's wet on this wall, we actually have to use, we can't use an air barrier any longer. All right. We need to have some sort of vapor barrier on this one. All right. So typically they're going to run a building paper, some sort of felt paper that's going to be moisture retardant that goes on there. They're going to put that felt paper on first, and that's what we're looking at in this section right here. On top of that, they're going to put their wire mesh. The wire mesh is what gives the stucco its strength. All right. Stucco, I want you to think of it as a mortar, a concrete of some sort. All right. It's a masonry type product. The thing with masonry type products is they're strong in compression. That's true, but they're weak in tension. All right. So when the house wants to expand, because wood will expand at a different rate as the stucco material will, it's going to want to stretch. And as that stretches, that stucco isn't going to want to stretch as fast as the wood does. All right. So it's going to be pulling apart and causing it to crack. And same thing if it shrinks, then we don't give it room to move, because it's not going to shrink as much either, that it's going to cause buckling to happen in there as well. Now mixing that mortar with steel, and that's what this wire mesh does, now that steel is going to be strong in tension, the stucco is going to be strong in compression. We put them together and we got ourselves a pretty good material that goes on there. Now we still have to make sure water doesn't get past there, because water is also powerful. And if water gets passed into the wire mesh or between the stucco and the felt paper on there, then A, the wire mesh is going to rust and degrade. B, when it freezes, that's going to expand and start pushing that stucco out and creating bulges in it. And eventually that stucco is just going to crack right off. All right. So the first coat, when we put mortar on, it's called a scratch coat. I do want you to remember that term. It's going to be the same thickness as whatever that wire mesh is. All right, that wire mesh is typically going to be about 3/8 of an inch thick, but it might be a quarter, it might be a ½ inch. They do come in different thicknesses. The thicker it is, the stronger it's going to be. All right, we're really not going to have the luxury of being able to tell how thick that mesh is. So I just want you to know roughly it's going to be somewhere around 3/8 of an inch thick. So they take that first coat, they scratch it. If you get the luxury of seeing stucco being installed and you watch the first coat go on, you're going to see the wire mesh pattern that's going to be visible through the scratch coat. You know, I mean, it's not, you're not going to see the steel. You'll see the pattern of the steel that's on there. All right, that's common. That's going to be our base coat. And then whatever that base coat thickness is, they're supposed to put a secondary coat. Typically, it's an uncolored, unfinished stucco. It's usually brown, all right, and that's why they refer to it as the brown coat. After the brown coat is installed and installed properly, we should not see any of that wire mesh any longer. And then we're going to end up putting our finish coat on there. The finish coat is the thinner coat that goes on. that has the color, that has the pattern, that has all our designs. Underneath all of those, and this obviously gets installed before any of the stucco is applied, is going to be our drip screed. Now, on this drip screed, we're going to actually have holes on the bottom here. So this does a couple things. It gives us kind of a base and something that's holding up the weight of everything else, and it does hold up some of the weight. I mean, it's the wire mesh that does most of the work, I get it. But the drip screed does something. And then it's going to have holes, so if any water does get in between here, we're afraid of that staying there and freezing, we're going to give it a way to drain out the bottom. All right. So 3-coat stucco, we need control joints. All right. Realize a house is going to grow and shrink, and if we don't allow that stucco to grow and shrink with the house, it's going to crack. It's going to buckle. And once we start cracking and buckling, then water is going to start coming in there. Anytime I run into any wood frame stucco home, I'm always telling my clients that they should have an annual inspection and repair of these. All right, they crack. All right, I want my clients to expect it to crack. All right, that is what they're buying. You want the stucco look, you got to take the stucco issues that come with it, and it does require maintenance. And a lot of stuff does require maintenance. When we're dealing with wood siding, we're going to need to make sure that that's painted or stained. The composite siding, we need to make sure that's well painted as well. But the stucco stuff here, once we start seeing those cracks come in there, they need to be sealed up, and many times it needs to be painted. My neighbor next door to us here has a stucco house on a wood frame building, and they don't do any maintenance to it, and neither have the previous owners done any maintenance to it at all. And I just end up seeing big chunks of this stuff falling off and coming to the ground, and then it just keeps bringing more water behind it, and then the next thing they know is they got a few $1,000 bill or more because they're hiring a stucco company to pull off all the loose pieces. And it's weird. You'll lose a piece that is maybe 1 foot by 2 feet, all right, little rectangle that comes off. But when the stucco guys come out here to repair it, they can't just fill that opening in, because all the other stuff's going to come as well. And so they're going to take everything that's loose, they're going to start hitting it with hammers, and anything where the mesh is rusted, loose, the water got behind it, separated everything else, they pull all that down. They ended up taking, I want to say it was probably about 12 feet wide, and then it was 2 stories tall. That they ended up removing. The only part that fell off was 1 foot by 2 foot, but what needed to be repaired was 12 feet wide, by 20 feet tall, and that was on the other side as well. They only had, because they ended up inspecting the whole property, or the whole building, I should say, and they found a bunch of loose pieces, and they removed all the loose pieces and gave her a bid, and they went ahead and repaired everything. Now, if you bring them back every year, the cost is going to be less. They're going to look for those cracks that are going to happen, and they're going to get those sealed up and prevent that water from coming in there. All right. Sorry, I went off on a tangent on you. 3-coat stucco, wood frame buildings. 2-coat stucco is going to be for true brick buildings. So we're not talking about brick veneers. We're talking about true brick buildings. All right. So the brick wall here is going to expand and contract at the same rate as the stucco material. So because of which, we're not worried about control joints. We're not worried about, we still have to maintain this. We still have to have it inspected, all right? But the cracking that you're going to find on a brick building with stucco will be far less than on a wood building. So first coat, same as before, about 3/8 of an inch thick. Notice there's no felt paper nor building paper. Notice that there's no wire mesh that goes on there either, all right? You're putting the mortar directly onto the brick. It's the same thing as a parge coat that we normally find in basements when we come with it. That's going to be our brown coat or our base coat. We don't really refer to it as a scratch coat because we're not going to see the pattern of the brick behind it. It should be nice and smooth and brown. And then on top of that, we're going to put a little bit thicker of a finish coat. Again, we mix our color, we put it in our pattern. No drip screed that's underneath this. No control joints. So if it's for a brick building, it's probably going to be a 2-coat process. If it's for a wood frame building, it should be a 3-coat process. All right. So we do find cracks. We do find shrinkage in the lumber that happens, especially on newer construction. So basically what happens, you buy wood when we build a house, it's wet, and then after a year or so the wood shrinks and dries. If we use nails to hold on to the mesh, that nail gets loose and pulled out. That's what they're showing on the left one here. The nail's not as far in as what it was. Then you get some wind push, or maybe somebody leans on it and it pushes that stucco back up against the stud, because here now you can see we got a gap in here, and here we don't have a gap. And when it pushes that back in there, if that nail doesn't move, if there's so much friction on the nail, then it's just going to pop out that section and bring it out of there. It happens. All right. So again, warning your client that this can happen, letting them know that it requires annual maintenance, and they're better off getting a contract with the stucco company in their area so they could have it checked and repaired and maintained on an annual basis. That's going to save the expensive stuff when big chunks start falling off, or God forbid they have to replace the entire thing. All right. So the next section here we're going to talk about is EIFS. I want you to know EIFS is an acronym. All right. EIFS stands for exterior insulation. I know it says exterior insulated, but I like the term insulation. Finish system. All right, exterior insulation finish system. Sometimes you'll hear people flip those words around and they'll call it EIFS. All right. So I really don't care, how you put the letters. I just want you to know what the letters stand for. So if it's exterior finish insulating system or exterior insulated finish system, whatever it is. Other common terms that people use are synthetic stucco, and I think the most common term you're going to see is drive it. Now, drive it is the name of a company. All right, it's a product that comes in there. Drive it was the first company, I believe, in Europe. All right, in Europe, when there was big battlegrounds for World War II, and they had a lot of buildings with these big gaping holes in them, from bullets and tanks and everything else, and they needed to seal up fast, make them look like they did, and make them livable for people. So they were able to slap on a bunch of styrofoam. That's our exterior insulation. Typically it's about 1.5 inches, 2 inches thick. It might be thicker, but 1.5 inches is the minimum. And they glue that on, or they did glue it on back then, and then they put the coats, they'll put a fiberglass mesh on there, and then they'll put a base coat and a finish coat on top of that, and it's really thin, but it does a good job when it's installed properly, and again, everything when it's installed properly. Now, what's good about Europe using EIFS installations is their structures, in fact most of the world, is made out of concrete. All right, it's pretty much only the United States and Canada, and if there's other countries that use wood frame, I'm not aware of them, but we're pretty much the only two that use wood to go ahead and construct our homes. All right, now concrete, well, it won't rot. All right, the problem has been when I brought this material here to the United States that now we're going to be trapping water in between there. If water got onto the concrete, it really wasn't all that big of a deal. But if water gets onto the wood, now we're going to get wood rot, mold, because wood is organic material, and then we get pretty unhealthy homes that come into it. So EIFS have become very litigious here in the States. The people that install the EIFS materials, and don't get me wrong, there's some very good, experienced, wonderful installers. There's some bad ones too. All right, And to take a class to be approved to put this on there, that class takes about 4 hours. All right, so you can take it any day of the week. They'll do it in the mornings and the afternoons. Drive It, Synergy, they put it on. This is how you install our products. Here's your books. Follow the rules. All right. If you want to get into inspecting these, and this is residual income, because it's such a litigious thing and there's been so many insurance claims on it, insurance companies are mandating that people do get EIFS inspections done. And typically it's going to be every 3 years. You're going to find a lot of people will do an EIFS inspection before, when they're listing it, so they could say, hey, this is inspected and it's okay. And I got to say, there's some good EIFS inspectors out there and there's some not so good. And I went through this one program. It's done through a company called Exterior Design Institute. I believe their website is edionline.com. But if you do a Google search for Exterior Design Institute, you should be able to find them. It's, I believe it's a 3-day, 8 hours a day course. So it's a 24-hour class. So, think about that. It's a 24-hour class to inspect the product, but it's a 4-hour class to install the product. And for me, it's always should have been the other way around. When we're going ahead and, the installers, the electricians, the plumbers, the HVAC guys, they should have far more education than we as typical home inspectors have. But it is a good thing if you want to get into it. You want to start re-inspecting these things every year or every 3 years, depending on the condition of it. There's a lot of people that do a pretty good market with it. So I don't. I just choose not to. All right. Now, in the real world, until you do become familiar with this stuff, I'm going to encourage you to disclaim it. Find somebody who is certified, someone who you trust, who's going to represent you. You can always refer it straight out to them. And you're welcome to contact me if you want names of people that I refer to. I'm more than happy to share that as well. So there's 2 types of systems, drainable and barrier. When the EIFS first came to the United States, I want to say it was, somewhere in the mid to late 90s, maybe late 80s, it started coming into it. But it really became a problem stuff into the late 90s and then beyond. We only put on the barrier systems, which means the styrofoam was glued on to the substrate. And that gluing, the water would get behind the EIFS. It would soak into the styrofoam, and it would just stay there. There was no way for it to release and get out. They wanted the barrier system because they felt the drainable system has a corrugated plastic behind it. The building code guys, they felt that the drainable system would not be able to withstand any sort of winds. And so they really didn't allow that system to be installed. Well, the barrier system, because it held water, created a lot more problems. You're going to find these type of wall claddings to be the most problematic in the areas where we have the highest humidity. So when you go down to Georgia, Florida, the southeast, it's very humid there. And you run into EIFS stuff, they're going to have far greater problems than they're going to have in New Mexico, Arizona, where the climates are very dry. There they have very few problems. Here in northern Illinois, in the Chicagoland area, we're kind of in the middle. All right, I know it's pretty humid when you get towards St. Louis. There's areas further south that are very humid, but we're kind of in the middle. We're not extreme humidity, but we're also not dry up in here. So we get less problems than what they get in the southeast, but more problems than what they get in the southwest. I do want you to know barrier systems are glued on. Drainable systems will have a corrugated plastic behind the styrofoam, so when water gets into it, that allows the water to drain out of the bottom. And pretty much everything that's installed now is going to be a drainable system. And to check for that, you want to look on the underside and look for that corrugated plastic between the structure and the styrofoam that you see underneath there. So, So EIFS is a multi-layered wall system. It consists of insulation board. It's styrofoam, all right? You know, whether it's XPS or EPS, either way, it's styrofoam, okay? And that's secured to the wall, whether we screw it in there or whether we glue it on, either way. We're going to end up putting a fiberglass mesh on there first, and then we're going to take our base coat, and that's going to go over the fiberglass mesh. Now, if this is installed properly, so if you are watching it be installed, if it's installed properly, that fiberglass mesh, we're going to talk about wrapping it around the styrofoam, around windows, doors, stuff like that. That's supposed to go behind the styrofoam, so it's what they call back wrapping. And again, we'll get to that in a little bit. And then, and when we put the first coat on, unlike the scratch coat on the stucco, where we're actually supposed to see the pattern of the metal, this we are not. All right, if we actually see the pattern on the fiberglass, it's too thin. And again, that fiberglass comes in different thicknesses, and it all depends on where it's going to be installed. So areas where it's down low, where bikes and people can bump into it and damage it, they're going to use a thicker fiberglass mesh there. Areas that are up high, where nobody's really going to be touching it, they're going to put a thinner coat up there to save some money. And then on top of the base coat, we're going to put our finish coat. Again, the finish coat gives it the color, gives it the pattern. You know, that's what we see and enjoy. All right. So I would like you to take a few moments and write down some of the stuff that we see here. There's also another organization. Please write this down as well. It's called IEMA, or EMA, I think is the proper way to say it. And it's also an acronym, and that stands for the EIFS Industry Manufacturers Association. All right, EIFS Industry Manufacturers Association. I'm going to try and put some links. In fact, I'm going to make a note so that I won't forget to put links to some of these things on here. Okay. So they have detailed drawings on how everything is supposed to be installed. And this list that we put up here, I'm going to talk about them. I'm going to show you some drawings and stuff. But these, you know, again, I'm still going to encourage you to disclaim this material, push it off to somebody who knows about it. But you, from what I understand, there are questions about EIFS on the National Home Inspector's exam. I don't know what they are, you know, but these are the ones that came to my attention. I think we should focus in on them quite a bit. So I'm going to see what else we got here. Give me 1 second, and I'm going to actually switch cameras here. Okay. And then we'll talk about these different things individually. All right. So that 2-inch clearance to the roof. All right. So what we're talking about is if we have our roof, and now we have a dormer section coming off here, we're going to end up having our EIFS siding as we come up. Many times you're going to see the vinyl siding and aluminum siding where they drop it right on the roof. All right. And it's wrong. We're supposed to have, we're talking about this area right in here, we're supposed to have a 2-inch gap. All right. So that 2-inch gap, I usually get a little lenient when I'm dealing with aluminum and vinyl but not with EIFS. All right. If I see driving on that dormer window, this 2-inch gap is important, and we need to see all the step flashing that comes in there. All right. Same thing on the grate. All right. I know it says 6 inches on there. Please forgive me. It's 8 inches. All right. So when we have our earth underneath there, we want to have 8 inches on the bottom of that as well. A 1/2 inch joint to dissimilar materials. All right. So if I have a window that comes in here, I need, and then I put my EIFS coming down the side of the window. We're talking about EIFS, window, dissimilar materials. I have to have a 1/2 inch gap on there. Now the reason why we want that 1/2 inch gap is something that's called 3-sided adhesion. So the next few ones kind of all go together a little bit. I like the chat. I'm going to take down these lights here just so I could have more room to write on. To chat what a good sealant actually looks like. All right. So let's take this area right in here. All right. We'll take our window and we'll draw our line right here. All right. So there's my window. And then we have our EIFS. And we come in here. All right. So at the top, and we'll give it a bird's eye view as well, we're going to have this. So this is looking straight down this gap right here. All right. The first thing we want to install is something called a backer rod. All right. If you don't know what a backer rod is a styrofoam rope. More specifically, it's a closed cell styrofoam rope. All right. What's good about closed cell is sealant or caulk doesn't stick to that. Nothing is going to adhere to that. And when we talk about sealant, sealant has two properties. You know, it adheres to things, and it's stretchable. All right. And I'm going to use that word, stretchable. I hope I used it right. So what we're going to do is we're going to take that rope and we're going to stuff it into these two gaps right in here. So as we look at it from above, we're going to have this closed cell styrofoam filled into there. All right. And then on top of that closed cell styrofoam, we're going to go ahead and put our sealant. All right. So our closed cell styrofoam goes up and down here. And then on top of that, we're going to put our sealant in here. And we're going to tool that sealant to create a concave look to it. All right. So as I make that concave look to it, the backer rod is also going to give it a concave feel on the inside where the backer rod is. We're going to give it a concave look on the outside where it comes with it. We're going to make it very thin in the middle. So when I make it thin, that allows it to stretch and get longer. All right. And then we make two fat sides where it's going to adhere to the window and the EIFS. So I give it a big area to adhere to things, and I give it a thin area to be able to stretch and move. This is the proper way that any sealant should be installed. What you see with a lot of problems is people don't put that backer rod in there. And let's just draw the same thing without the backer rod. And of course, we're going to have our substrate up in there that I didn't draw earlier. All right. Now, if I fill this whole thing in with sealant and we still tool it, all right. Now what happens is I have 3-sided adhesion. So I got a big, thick glob, kind of like a rubber ball, all right? When these things want to spread out, something's got to give. That is so strong, so solid, it's not flexible. So either I'm going to rip on the side, All right, and that's going to be known as adhesive failure. And I think you see that as one of our choices there, where it pulls apart from the adjacent surface, or it's plain out going to rip right down the middle. So it's not going to be cohesive. It's not going to stay together. All right, so it's either adhesive failure or cohesive failure. But the chances of that happening when I put the joint in right, like what's on top, is pretty slim. All right, so using that backer rod is important. I do want you to know what three-sided adhesion is, and so that's when I get joints. You can see that like on bathtubs, and you know they tell you buy a 50-year caulk and it lasts for 2 years. And the reason is, again, there's my joint inside there, and I go ahead and I put my sealant in here. There's no room to move. You know, so if that tub flexes at all, something's got to give. Whether it's going to rip or whether it's going to come apart from being adhesive, something's got to go. All right. If this interests you, do a screen snap real quick. I'm going to erase this because I want to keep drawing. I think they come up with good quality whiteboards that just seem to erase better. You know, maybe I just got a crappy eraser, but it's always I have to wash this thing every time I use it. All right, next term is going to be back wrapping. So we got our sheet of styrofoam, and again, I'm going to do a bird's eye view of that styrofoam. What we're going to do is take that fiberglass mesh, so it goes on the front, but then it's going to wrap around the sides and come back. So that fiberglass mesh is going to come all the way around. This is called back wrapping, all right? And it's same thing on the bottom, all right? So it's going to go behind it on the bottom. If I had a window in here, it's going to go behind the windows. And if it was a door, same thing. You know, it would go behind and back wrap the styrofoam on the door. Sometimes they refer to lintels, because this is actually considered a masonry building for tax purposes, which is kind of nuts. So it gets taxed the same as a brick building. I guess they're at a higher level for whatever it is. And EIFS would get taxed the same way. So you do have to have lintels to support the top of the windows up in here, but because that lintel is the actual fiberglass mesh, I've heard of people getting a question, which I think is almost absurd, but that's my opinion on it, so it doesn't really matter. They ask, what material is the lintel for EIFS made out of? Well, we're not going to put a steel angle iron that we're familiar with lintels when we're dealing with brick buildings. We're just going to wrap the fiberglass around there, so that's going to be made out of fiberglass materials. Next term here is going to be a butterfly. So butterflies happen around windows. So this is a mortar product. And mortar products, as they cure or dry, because they're put in wet, as they cure or dry, they shrink, all right? So as they shrink, they're going to be pulling away in all different directions. If I got a window right here, that window is an opening, so things are going to be pulling this way and this way. That's going to make this area here a pretty weak area. So even in basement windows, when you see the concrete, often you're going to see minor cracks coming from these corners, all right? So because we know that that's normal, we know it's going to happen, what we're going to do is put something called a butterfly strip. So they take that fiberglass, you know, the stuff that they back wrap all the way around here, and then they double that up in these corner areas. They make it twice as thick, all right? If it was over doors, they make it twice as thick that comes in there. They're trying to prevent this cracking, and it works, all right? I want you to know the term butterfly straps and what they mean, All right. And then for horizontal surfaces, all right, let's say we had a window. All right. So here's my wall. And then I got a window here. Yeah, we'll just come all the way down with that window. So I got water coming down, or we'll just say this is my wall, there's my eaves. Water's coming down this way. I hit this surface. If I'm going to wrap this with eaves, it can't be flat. All right. It has to have a slope of 6 and 12. That's the minimum. And truthfully, all brick has to have that slope 6 and 12. All right. And you'll find many times when somebody just puts brick laid up in a header pattern, they just leave that kind of flat sitting on top of that for the look. But that really should be tilted in that 6 and 12 pattern. We don't get too many of a problems with that just because of the way everything's flashed with the bricks, and we don't have that big of issues. But when we're dealing with this stuff, when we're dealing with this eaves, we can't be that lenient any longer. All right. So it's too litigious. If we see this sort of stuff, we do need to call it out. All right, so let's get back to our slides. We covered 2-inch clearance to the roof, 6 inches, 8 inches above the grade. My apologies for that. 1/2-inch joint to dissimilar metals. We talked about backer rod, sealant, how we make it thin in the middle, thick on the sides. Issues with sealant is going to be cohesive and adhesive failure. 3-sided adhesion. If we have the backer rod on there, we won't have it. The problem is if we don't give it room to move. We talked about back rafting, butterflies, no horizontal planes, 6-12 minutes. Kickouts. I did not talk about kickouts, and I'm going to flip over to that slide